Hello everyone. In this video we'll be doing the free responses for Chapter 5, the probability, and we will start with the 2001 number 3. So hopefully you've already read this because you should have already tried it on your own. So I'm just going to summarize, but if you need to pause the video and read it again to refresh your memory, go ahead and do that. But what's happening in this free response is they hand out coupons, which are just numbering people 1 to 50. Right? And so then on Saturday, they draw numbers 1 through 50, and if they draw a number, they give out a cash prize. And so if they draw 1 through 5, they give out $200, 6 through 20, they give out $100, and 21 through 50, they give out $50, and they keep drawing numbers until they've given out $300, right? Until the total amount first equals or exceeds 300. And so they say, explain how you would conduct a simulation using a random number table provided below to estimate the distribution of the number of prize winners each week. So how you would start this off is you would use this format that we talked about at the beginning of reviewing Chapter 5. Okay, so I'm going to try to stick close to that to help it make sense. So we would use what numbers. We're going from 1 to 50, but we ought to make the digits match. So 0, 1 to 50 for coupon winners, and that's everything that we need to include, right? So that's what we want to include, so we need to ignore. Normally you have to assign different numbers, different things, but in this case it's just 0, 1 through 50 coupon winners, and that's it. And ignore what? So that means 51 through 99 and 0, 0 and repeats, right? You can't give out two of the same number. Ignore, and now what we're going to do is you're going to count each amount given based on assignment. Up here, I'll say based on cash assignment. So count each amount given based on cash assignment until what? When do we stop? When we equal or exceeds $300. And then we will record how many because what do we care about? The number of prize winners each week. Record how many prize winners. And you just have to and then technically you would repeat that process, but you just have to describe one simulation. So that is explain how you would conduct your simulation using a random number table provided below to estimate the number of prize winners. So always at the end say record whatever you're interested in. Okay, so then B is we're going to actually do this 3 times. So if you wrote this out good, you should be able to follow it. So if you notice when we do B, we kind of like don't follow what we wrote. Maybe we need to go back and change what we wrote. And it says, start at the leftmost digit in the first row of the table and move across. Make your procedure clear that someone could follow what you did. You must do this by marking directly on or above the table, so they want to see your work. And then report the number of winners for each trial. So we're going to go by 2 digits, right? So the first number is 72, which that is something that we're going to ignore, so you show that you're crossing that off. 74 you ignore. This would be 91, ignore. Then we have 33, so I'm going to circle 33, and we'll care about the cash assignment to that. So what is 33? How much cash does 33 get? Anything above 21 gets 50. So that is $50. Then you have 47, so that's another 50. And we're going to keep going until we add up to $300. So 65 we would ignore. 0, 3 is 1 through 5, so that gets 200. So if you notice, we reached 300, so that's your first, that's where they would stop. So draw a line to show your first trial. Okay, so what do we care about? What are we recording? Report the number of winners. So how many winners did we have? We had 3 winners. So for trial 1, we had 3 winners. And now we're going to do it again, starting where we left off. So now it's 0, 2. So that's $200. 61, cross off. 28 is $50. 49 is $50. So wouldn't that be 300 again? So you draw a line to show you ended. So that would be another trial. And in that trial, by the time we reached 300, we had 3 winners again. And now we're going to do one more trial. So 0, 6 is not 100. 6 through 20 is 100. 70 you cross off. 29 is 50. 0, 4 is 200. So we exceeded 300, which is okay. Just when you first exceed it, you stop. So for trial 3, we also had 3 winners. And if you wanted to, you could go back. I mean, showing the lines should be sufficient, but just because it got a little messy, I'm going to say that this was trial 1. This was trial 2. And this was trial 3. So then that's all it asks you to do. You're done. If it asks you about, so then using that, what's the probability of having 2 winners? Well, none of our trials had 2 winners, so it'd be a probability of 0, which we know is not necessarily true, but based on our results. Okay, so then on the next page, it's kind of, this is more using the formulas for probability. So we have our 2 formulas for probability on our formula chart. And then we also have the idea of how to solve for independence, which we put here. And we know if they're independent, then we have this other formula for the probability of A and B. So it's kind of like you have 4 formulas and only 2 are on your formula chart. So let's go ahead and get started. A says, if an adult is to be selected at random from this sample, what's the probability that the selected adult is a college graduate or obtains news primarily from the internet? Could not read that for some reason. So or is this formula. So we're going to use this formula. So for A, we're finding the probability that a randomly selected adult is a college graduate, or, so you can write the word or you can use the union symbol, obtains news from internet. So this college grad is like your A, news from the internet is like your B. So we would set up our formulas. So that would be the probability of being a college, if I could write, college grad plus the probability of getting your news from the internet. But then, you can't forget this last part, subtract the intersection. Minus the probability of being a college grad and getting your news from the internet. Because if you don't subtract that, then you double counted those people that are both. So let's go ahead and set this up. What's the probability of being a college grad for this sample? Well, how many were college graduates? The total college graduates was 693. Out of the total in the sample is 2,500. Plus, what's the probability of getting your news from the internet? So the total that got from the internet, 687, out of the total in the sample. Minus, what's the probability of selecting someone that's a college graduate and get their news from the internet? So you got a college graduate and getting internet news is 245. See, because that 245 was in this total and that total, you got to subtract it so you don't double count it. And if you do that math, I think I already have it, that would be 1,135 out of 2,500. You just add and subtract the numerators, and if you get that as a decimal, that's 0.454. Okay, so then question B. So that's your answer, if that wasn't clear, 0.454. Question B is, if an adult who is in college is to be selected at random from the sample, what's the probability that the selected adult obtains news primarily from the internet? So this is worded different, right? It's if they're college graduate, what's the probability? So that if statement is given. It's given they're an adult who's a college graduate, what's the probability of getting your news from the internet? So how would we set this up? We're finding the probability of, remember your given has to go second. So we're finding the probability of getting news from internet. Given they're a college graduate. So if you look at your formula for given, it's the probability of A and B over the probability of the given B. So what that would look like in context would be the probability of getting news from internet and being a college grad over the probability of the given, which is the probability of being a college grad. So in this case, you could just use the amount since it's all out of the same total. I'm going to stick with probability. So if you did this different but you got the same answer, don't worry about it. But to stick with this idea of using the formulas and probability, what is this going to be? So what's the probability of getting news from the internet and being a college grad? Well, we already said that here, right? News from the internet and a college grad is 245 out of 2,500. Again, this is where I'm saying you don't have to use that total, but over, what's the probability of just being a college grad? College grad would be 693 out of 2,500. So you could type that whole thing in your calculator. Also, if you have the same denominator on both, it would simplify and it would just be 245 out of 693. And if you type that in your calculator, it is 0.354. Okay, give me 1 second. And for C, it says, when selecting an adult at random from the sample is 2,500, are the events is a college graduate and obtaining news from the internet independent? So how do we determine independence? Where's my, got too many papers over here. It's given one, it doesn't change the probability of the other. So I'm going to go ahead and write this formula down. And like I've been putting it in context, you can do that here. And I'm going to show you another way you could do it if you want to use A and B. So to prove independence, A given B needs to be the same probability of A and the opposite, the probability of B given A needs to equal the probability of B. If both those things are true, if those do equal, then A and B are independent. If we go do this first one and that's not equal, then we don't even need to do the second one, because if one's not equal, then they're not independent. So if I want to use just A and B, I need to define. I'll make A, it doesn't really matter which one's which in this case. A can be being a college grad, and B will be getting news from internet. So if you're using a formula, you can either just put the words in the formula, or you can use A and B and just define them over here. So let's set up this first one. The probability of being a college grad given you get your news from the internet. Is that the same thing as here? That's not. But couldn't I have switched it? Because you got to prove both of these anyways. So since I've already done this one, I've done the probability of getting your news from the internet given college grad, I'm going to focus on this formula technically instead of that one, because you can use either one, because technically you got to prove both. So I'm going to come over here to show I'm doing this same thing. And we know that that probability of B given A equals 0.354. You don't have to re-show that. It shows that we know to use our answer above. So then what does that make the probability of B, which is getting your news from the internet? Well, how many got their news from the internet? 687 out of 2,500, which is, do I have that in front of me? 687 divided by 2,500 is 0.27. And we can see those don't equal, right? So the probability of B given A doesn't equal the probability of B. So because they don't equal, they're not independent. Not equal, not independent. Equal, independent. So we'll say, why? Because knowing one changed the probability of B. So you don't have to write that out. Your math is sufficient. But we'll say A and B, and I can use A and B because I defined it. If I didn't define it over here, you would need to write out college grad and news from the internet, but I'm running low on room, so that's why I defined it. Are not independent. And you should be able to just leave it like that, but if you have the time or space, you can say because the probability of B given A did not equal the probability of B. So there are your free responses for Chapter 5.